Hi everyone. Uh, Fundamentals of growth and development. So in the development of large muscles and the achievement of mobility, the typical child of 2 years is comparable to the chimpanzee of 2 months, the rabbit of 2 weeks, and the goat of 2 hours. Yes. After 2 hours, the baby goat could walk. Okay, so you see the differences here. So you can see the enormous differences in heredity and rate of maturation between human and animals. On the other hand, language acquisition seems to be entirely and exclusively in the domain of human capacity. So this is true, even though some researchers have identified that animals could communicate, but then their language capacities are very, very limited. All right. Now, of all the great debates in the history of psychology, the one that generated the most heat, right, and caused the greatest division in the field is the controversy over nature and nurture, or heredity versus environment. Right? Now, let's take a look at the nature-nurture controversy. Okay? Nurture is a term coined by Francis Galton, that is Charles Darwin's cousin. All right. Now, take a look here. The hereditarians who favored nature claimed that all psychological traits were transmitted through the genes from generation to generation. Environment was of little consequence. In general, they say if your father was a horse thief, you would be a horse thief. And if your mother were a genius, then your sister and yourself must be genius too. That type of thing. You know what I mean, all right? And so the heredity camp consisted at that time mainly of management practitioners. All those people like Francis Galton, Cattell, Stanley Hall, and Lewis Terman. All of these people, they were involved in IQ testing. And the environment, they are from the behaviorism camp, right? Like John Watson, Edward Thorndike, Guthrie, Hull, and B.F. Skinner. And we will talk a little bit more about this later on, right? Now, take a look at the example the example put forward by the nature side, okay? The hereditarians claim that all psychological traits were transmitted through the genes from generation to generation. Environment was of little consequence, right? So they put forward Tryon's 1940 experiment. A group of rats, learning a maze, and a group of rats, they were randomly assigned to rat twins, assigned to two groups, all right, two groups, all right. So one group identified to be quick learners, another group slow learners. They have two different groups. Okay, sorry, I forgot. Two different groups. Now, the quick learners, after breeding, you see, after 7 generations, after 7 generations, Then what? They discover at long last, this is what a maize bright group. And for the slow learners, after what? Internal breeding, then eventually they form what Tryon called the maize down group. All right? So let's take a look at the nature-nurture controversy. Okay? The environmentalists claim that a person's whole being was shaped by how and in what circumstance one was raised or nurtured. Genetic endowment was the romantic myth used to keep king on the throne, but of no use to science. Right? The environmentalists, however, held that all people were born equal and that later differences among them were only a result of different environmental opportunities. Okay. So this group aligned itself with the prominent British philosophy, John Locke. John Locke, 1691. Well, he said that the mind is like a blank slate upon which experience writes. But that's a famous statement quoted by a lot of people. So as far as the environmentalist is concerned, the baby is nothing more than a lump of clay that can be molded and fashioned into any shape by the environment or through the use of conditioning techniques. Now, what kind of conditioning techniques? But anyway, we'll come to that now. Let's take a look at one. Take a look at one. Take a look at this one here, okay? IQ test. Okay? IQ test, all of these people here. Okay? Francis Galton, back in 1869, and of course later on 1883 and 1892, designed and created the first test to measure intellectual potential. He believed that intellectual potential was a function of one's sensing equipment. One's power to discriminate among stimuli, like reaction time experiment. He believed that sensory equipment was inherited, and hence IQ was inherited. So Galton was a student of Cattell, and then independently Pearson, at the same time of Galton, Pearson, the Pearson product moment correlation. You remember that? Okay? Pearson single-handedly derived the formula for correlation. And of course, Francis Galton did the same too, independently. All right, and you see here, Stanley Hall believed intelligence was primarily inherited. So he was the first one to translate the Binet intelligence test from French to English. And Louis Terman took over in 1916. I think we would come to this when we discuss IQ testing, if time allows. All right. Anyway, so Terman created new norms for the Binet test based on American standardization group. He revised so many of the original forms as to practically create a new test. So back in 1916, and therefore, because Louis Terman was affiliated with Stanford University, and therefore the Binet test, after translated into English, it was what called the Stanford-Binet, and is still called the Stanford-Binet intelligence test. All right, now let's talk about environment, behaviorism. Well, these are the famous names here, like Watson, Thorndike, Guthrie, Howell, and Skinner. They saw, all of them, they saw learning as a result of associations between SNR, stimulus and response. These simple associations would accumulate and form larger groups of learned association. So learning was seen largely as a result of condition, similar to what Ian Pavlov's dog learning to salivate at the sound of certain tone. Ding! I remember that classic one, psychology's classic experiment. Now, nurture. Let's take a look at nature, and let's take a look at nurture here. The environmentalists held that all people were born genetically equal, and that later differences among them were only a result of different environmental opportunities. Genetic endowment was a romantic myth used to keep kings on their thrones, but of no use to science. And of course, here John Locke, mind is the blank slate upon which experience one writes. Okay, so you see here, John Watson, he conducted a very famous experiment, a horrible experiment. Okay? He borrowed Pavlov's finding on the conditioning of dogs. He conditioned a 9-month-old baby named Albert to fear a whole variety of objects. Okay? Take a look here. White rat. It is what? White rat is a conditioned stimulus. Okay? And a loud sound paired with loud sound. Loud sound is what? It's what loud sound usually would elicit fear. So that's called unconditioned response. Anyway, we'll come to this in detail later on. Okay? So white rat paired with white rabbits, okay, fur coat, cotton, wool, etc., will produce what? And together with the loud sound, a loud gong, just inches from poor Albert's ear, gong, okay, and together with with the presentation of white rat, white rabbit, fur, and so on. Of course, here the loud sound inches from the ear would produce fear. But when the loud sound was paired with all this here, then later on, the white rat alone would produce fear. Okay? Just like in Pavlov's experiment, the tone by itself later on could produce salivation in the dog. All right, so you see here, that is using classical conditioning. Okay, all right, so that's good. And of course here, I forgot here, through a process called the stimulus generalization, the fear is generalized to the white rabbit, fur coat, cotton, wool, and so on, even though these were not involved in the original experiment. Okay, so that's called the stimulus generalization, and we will come to this in detail later on in the course. Okay, all right. Now, Well, before we move on, why was an environmental position so attractive in America? Okay? American psychology was dominated by liberals who lined up the side of the environmentalist. Okay? To their way of thinking, heredity doomed humans to a racist society, and that's true, right? That's true. So the nature-nurture argument was rephrased in more democratic language as instinct. Instinct versus what? Instinct versus learning, or even beast versus what? Man. That type of thing. Okay? Even some recognize the importance of genetic influences. They found that heredity was fixed at conception, and that there was no point in studying something that couldn't be changed. So environmental influences, on the other hand, could be manipulated, and hence heredity becomes unimportant simply because of its inaccessibility. Right? Good argument. Genetics as a discipline is a relatively new field at that time. Okay? Very few psychologists were familiar with the information that was accumulating about genetics. Okay? Okay, all right, so, and then what? Then later on, the special field of behavior genetics is of very recent origins, all right? But what? The Giants 1940 classic experiment of breeding maize bright and maize dull rats. And as I mentioned, after 7 generations, he created two significantly different groups. But breeding experiments like these came after many of the behaviors had already made their strong environmental statements. So it's too late to be of any use. Anyway, the long-term damage done by what? The instinct theories. Remember what? Introspection. Okay? At the turn of the century, the turn of the 19th century, they called everything, or minute feelings, or emotions as instinct. So therefore, we ended up with thousands of instances. That did not help psychology to make progression. All right, so the behaviors, they kind of heavily criticized the instincts theory as dangerous. They pointed out that the theory confused description with explanation. This is called the nominal fallacy. Okay? They just assigned a label to the instinct without explaining anything. Alright, so let's go to ethology. Ethology is the study of animal behavior, okay, in the natural setting. So it was the ethologist finding that forced the American psychologists to evaluate their position on instinct and the role of heredity in determining behavior. So what ethology looks for, IRMS, innate release mechanisms, right? Innate release mechanisms. Releasers are those stimuli in the organism's environment that trigger unlearned behavior patterns. Now, the key word here is unlearned. They have never learned this type of behavior. So the big name, of course, here, Konrad Lorenz. You must have read about him in Introductory Psychology. Okay? Konrad Lorenz coined the term imprinting. Right? Newly hatched chicks, okay, goslings and ducks, they seem to follow the first moving stimulus they see within the first few hours of their life. So the first few hours of their life, that's what here, this is called the critical period. Okay? And then what Konrad Lorenz observed what he called imprinting. Okay? Imprinting. What is that here? Imprinting provided the perfect example of careful blending of heredity and environment in producing behavior change. So you see here, cherished beliefs breed narrow-mindedness, as often happens when narrow or even single course, okay, they are sought to explain anything. As a result, controversy is created and scientific vision clouded. The hereditarians emphasized heredity at the expense of Of environment. And the environmentalists emphasized environment at the expense of heredity. All right? But then behavior is actually it's a function of heredity interacting with the environment, interacting with time. They say imprinting is is a very good example. Is that now most of the time baby duck will follow the mother duck wherever she goes, right? You must have seen that sometimes even in highway or in city, on city streets, all right? And Konrad Lorenz was successful in getting the baby ducks to follow his shoes, because that was during the critical period. Baby ducks only saw Lorenz shoes. All right, so that's the critical period. Within that critical period, something must happen. Okay, so therefore, to trigger that kind of behavior, we will come to this very soon when we discuss critical period, like bonding between parents and the baby and the newborn baby. All right, so psychology's first principle and the most fundamental axiom is that the behavior is a function of heredity interacting with environment, interacting with time. Right? So the old question of heredity versus environment is unanswerable because it is meaningless. Okay? It is meaningless. Behavior is not the result of a single course, but of multiple courses. Okay? It is the result of heredity interacting with the environment, interacting with time. Our hereditary potential can be nourished or stifled depending on the type, amount, and quality of our environmental encounters, and also depending on when these encounters occur. The critical period theory. They can occur too early or too late to be of optimal benefit. So we need to look at nature and nurture simultaneously. We can then begin to consider, not in a single or narrow-minded way, but within a broad context, how to educate children and adolescents. And we need to know both how to psych and when to psych it. All right? So now, take a look at this. I believe we are all born equal, okay, except those ravaged by diseases. All of us have the same potentials for growth, the same potentials bestowed on human beings. Now, I'll give you a very good example. If you talk, or if some arrangements have been made to have people talk to you, or talk to a 2-year-old child in 10 different languages. 2 years old, okay, 10 different languages, consistently for a couple of years, say from 2 to 5, okay, the child can pick up these 10 languages without any strain, okay, without any difficulty. See, this is called the critical period. Okay? Is that human being, we could pick up languages within the age of 2 to 5, just like this, okay, just like this, okay, with no difficulty whatsoever. All right. So this is heredity plus environment plus time, the critical period. All right, the critical period. All right. So let's take a look at physical growth and development. Okay, and development. The zygote is formed at the moment of conception, when the sperm cell of the male fertilizes the egg cell of the female. Of course, here half of the genetic materials, or half of the genetic background contained in the zygote comes from the father, half from the mother. Okay. Now, let me talk a little bit about genes, because gene has to do with genes. There are DNA, RNA in the gene, and then nowadays we have the mRNA vaccine, that type of thing. So genes are tiny particles that carry the hereditary characteristics. Okay, they are located in the nucleus of each of our cell, our body's cell. All right, and where they occur in pairs, one from each parent. So genes are composed of DNA and RNA, okay, located in the chromosomes, which lie in the nucleus of every cell, of every cell, okay, the nucleus of every cell. And there are 23 pairs of genes, okay, if I remember correctly. DNA consists of chains of atoms and molecules that code and store information about growth and development. It can reproduce itself exactly, so that is to say, to achieve self-duplication. Now, RNA is the coded information in the DNA molecule. It's transmitted to let me put it another way. The coded information in the DNA molecule is transmitted to the other parts of the cell by what? By RNA molecules. So the information contained in DNA to make sure that what here we grow to become a human, not a pig. Okay, that information is transmitted to the RNA molecule. So in a way, DNA acts as a blueprint for the formation of certain enzymes, okay, that help to guide the development of the organism. DNA can be thought of as the architect's blueprint, while the RNA would be the builder, translating this blueprint into a finished home. So DNA makes sure we humans won't grow into a pig, and vice versa. So RNA, in a way, enforces this. All right. So you see here, the mRNA vaccines here are a foreign RNA carry the message, telling our cells to what? To create a spike, the spike similar to the virus. Okay, so that our body would not recognize it as our friends. Okay, then the body immune system will kick in. So that type of thing. All right. So let's take a look at what zygote. If the zygote remains in the uterus and the uterine environment remains healthy, the zygote will begin to differentiate into three parts. Okay, you know what? Three parts here. Okay, the outer layer called the ectoderm, okay, which will form the brain. Okay, first, the middle layer called the mesoderm, which will form the heart. Okay, the inner layer, endoderm, which will form the liver. The liver is here. So the zygote is very small. Okay, during what conception. Now take a look at the what? Take a look at the embryo. Right? Take a look at the embryo. The what? The embryo's stage begins 2 weeks after conception. At the time the zygote attaches itself to the uterus, this stage lasts until about 8 weeks after conception. So take a look here, take a look at the diagram. Okay, now during this stage, the organism here, the weight increases by 2 million %. Right? The heart begins beating, sex organs are formed, hands and feet are formed and can be flexed. Okay? All internal organs are formed. Okay? So don't look at it is very, very small, right? But then everything is in. Okay. So therefore by the end of the embryonic stage, the organism is clearly identified as human. Okay? And if you want to learn say whether those of you who are religious, whether the spirit is already in the fetus. Okay? Read the book called "Embraced by the Light" by Betty Eder in 1992. You will be enlightened. Okay, you will be enlightened. Okay, the fetus from 8 weeks after 8 weeks after birth. Okay, 8 weeks after conception to birth, okay, to birth. The fetus is definitely a behaving one organism. You see here, it reacts to stimulation of the nose, lips, and chin. Okay? The area of sensitivity gradually increases, and by the 14th week, the whole body is sensitive. The fetus can also act spontaneously, like this, okay? It's called fetal activity. Sometimes it will kick the mother, okay, or punch the mother. It's true, okay, it's true. So movements are slow and masked. Masked means what? Like the whole body will move, okay? Not like moving this, just the fingers. No, they couldn't do that, okay? So, for example, touching a baby's foot, of course, inside the mother's womb, okay? Touching the baby's foot doesn't result in just the foot response, but is usually followed by gross movements of both feet, both arms, and even the trunk. Okay, why? Okay, we have to talk a little bit more about our nervous system. Now you see here, this is what? This is the cell, okay? You have what? Dendrites, and then you have what? Nucleus, you have dendrite, you have what? Nucleus, and you have what? Myelin. The myelin is what? You see this diagram here. Without myelin, this is with myelin. With myelin, it's just like here, like electrical wire. Our electrical wire has what? The copper wire is what? Is wrapped inside of plastic, is that right? So the plastic is actually the myelin, okay? That's insulator. So therefore what? The electricity won't leak out. Similarly here, our cell, the neuron, conducting what? Electrical impulses, okay? So therefore what? Later on you see there are what? Synapses. So one neuron communicates with another neuron through synapses, okay? Through synapses. And without what? Insulation, there would be a lot of what? There would be a lot of leakage, is that right? Now, the fetus, the insulation, the myelin wasn't formed at that time, or prematurely formed. So a lot of short circuiting, and therefore the mass movement, okay? Mass movement, not differentiated. All right. So, so you see here, it's not complete, is that right? The myelinization of the nervous system is not complete at birth. Therefore, what a great deal of what short circuiting among the babies, what neural impulses occurs. All right. Now, take a look here. So you see what? This is the case, is that right? This is the case. So an embryo's brain produces many more neurons or nerve cells, okay, more than it needs. Therefore what? Therefore the brain will what? Will eliminate the excess. So those that do not conduct electrical impulses will with them. Okay, will with them. All right. So the surviving neurons spin out axons because of stimulation. Okay, because of stimulations. The long distance transmission lines of the nervous system, the axons, okay? And then the axon, you see here, this is the axon, will be in touch with the dendrites of another neuron, and information travels in this way, okay? So spontaneous bursts of electrical activity strengthen some of these connections, while others what the connections that are not reinforced by activity, or that will what go through what entropy, they will die. They will die. So after birth, the brain experiences a second growth or spurt as the axon, okay, you know, the narrow one here, okay, narrow one here, the axon, okay, as the axons one, which send signals, okay, and dendrites, the dendrites, you know, the dendrites one here, we have all the dendrites, all right, and the dendrites, all right, which receive them, they explode with new connections. So electrical activity triggered by the flood of sensory experiences, okay, fine-tunes the brain's circuitry, okay, determining which connections will be retained and which will be pruned, okay, deleted. All right, so you see here, now look at the beautiful diagram. That is when the baby, a newborn, okay, in the hands of the mother. Beautiful, isn't it? Okay, so held beautifully by the father. Okay, so that's beautiful. Okay, now take a look here. Okay, the number of typical nerve cells never increases after birth, okay? But the size of these cells does increase. However, recent findings negate this. Even our neurons could be regenerated. Okay? Now, but then what I put down here, the alcohol kills or brain cells, okay, which now never regenerate, but then what? Some do regenerate, okay? Toxic agents in the mother's uterus can modify or even damage or halt the development of zygote, okay? And strong emotional arousal on the part of the expectant mother can be transmitted to the developing fetus in the form of specifically released hormones, okay, like cortisol, stress hormones, which can pass through the placenta and change the physiology of the unborn child. So remember, behavior is a function of heredity interacting with environment and interacting with time. Okay, so this is the first equation in psychology, non-mathematical. Okay, it is very important. So that is to say, we cannot just emphasize heredity, but then environment plays a very important role, and of course time, as you see in the forthcoming stage theories we are going to discuss. Okay, time is of critical importance. Okay, so we need to know how to strike and when to strike it. Okay, but all right, that's good. It is a rather long lecture. Okay, thank you. Okay, thank you.